Okay, so welcome. I'm going to be going over the 12-week exam from fall AC year 2025 for EC310. So this is for the signals part of the course for anyone taking the experimental version. This will be the material on your final. So first up, number one is a communication systems question. And we're looking at a waveform. For this type of question, it's really important to read the description of how this system works, right? They may be slightly different, and we have to make sure that we're looking for the right things when we analyze the signal. So we're using a return to zero line coding scheme. A 0 bit is 0 volts. A 1 bit is a 4 volt and returns to 0 at half the bit duration. So we're looking for, just that shape for a 0 and this shape for a 1, right? Um, so that's what we're going to be looking for on our diagram below, something like that, in between each of the dashed lines. And then it says there are 2 start bits and 1 stop bit. Start bits are 1 bits and stop bits are a 0 bit. So again, just stuff to remember. Information being sent as an ASCII character, 8 data bits, and the data bits are transmitted in reverse order. So all stuff we need to know here. So first off, part A, on the graph above, write out all of the transmitted bits above, including the start bits and stop bits. So here we'd have a 0, right, because it's just at 0. This has the shape where it starts high and goes low, so that's a 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. All right, so those are all the bits. We will need to do a little more decoding for part B, which is what ASCII data was transmitted by the system. So we know that this is set up to be an asynchronous signal because there are 2 start bits and 1 stop bit. So we have sort of 2 bits to identify where the signal begins. And that means the first 2, this is a start, this is a start. And then we've got our data bits. So this is D0, D1, D2, D3, D4, D5, D6, D7. So that's our 8 data bits that we've got transmitted. And then this is our stop bit. So that's what we should see. We know that these are sort of written out. So if we write out our data bits 1111, 1100, they are in reverse order. So we're going to need to flip this. So this becomes reverse. That becomes 0011. 1111. So we're just reading it left to right and writing it right to left. Yeah. And then from there, we need to convert that to hex. So that becomes OX3F. And then if we look at our handy dandy ASCII chart, which I'm not going to pull up just for the sake of space and time, you can see that that turns into the question mark character. So that's our final answer is question mark. Sorry for bad drawing. So part C, is this a synchronous or asynchronous system? Answer below. Since we have start bits usually mean that we have sort of a dead line naturally, normal voltage and idle wire, and then there's some sequence that starts up the communication. And so that sequence starting up the communication means it's an asynchronous system, right? We're not sort of like constantly talking. A synchronous system would have like sort of a no-op that we are consistently sending until we send a real message. Whereas asynchronous usually has these start and stop bits to identify where a sequence is. Is the sequence being transmitted an analog or digital signal? Since it's just ones or zeros, this is a digital signal. If it has, multiple values that they're not just 0 or 1, then it would be an analog system. The communication system uses a serial interface. If the entire transmission, all 11 bits, takes 5 microseconds to transmit, what is the bit rate of the system? So this is just bit rate is, bits over time. And so we're going to have 11 bits over 5 microseconds. Do your conversion to seconds there. And then we end up with 2.2 megabits per second. So this is just dividing 11 by 0.0005 seconds. and that gives us 2.2 million bits per second. Part F, a new transmission scheme uses a parallel interface using 4 parallel channels, with each channel having the same transmission rate from Part E. What is the bit rate of the new transmission scheme? So same transmission rate from Part E, ignoring any sort of complicating factors of how long the transmission is or anything like that. If we have a bit rate of 2.2 megabits per second for one channel, we multiply that by 4, we should end up with a transmission rate of 8.8 megabits per second. So really just saying that if we transmit this in 4 different places at once, or 4 different ways at once, then we multiply by 4. That's it for question 1.